All right, welcome everyone. Thank you so much for joining today. My name is Bo. I'm going to give a quick little intro, show you how to find today's presenters on Acelab so that if you have any questions after today's webinar, you can easily reach out over there. My colleague Arman has joined the call also. He's just going to give a quick description about Acelab. We're helping out with hosting today's event and explain how Acelab works with architects. So we'll just go over that while folks are joining. And then right after that, we will start the live CEU portion presented by Mark Brusso from Block-Lok / Hohmann and Barnard. All right, looks like we've got quite a few folks joining already. So without further ado, I'll start off first just explaining to you on Acelab how to get in touch with Block-Lok easily. So everyone who registered for today's webinar had an Acelab account automatically made for them. It's completely free to use. So you can just head to acelabusa.com to be able to reach out to manufacturers directly. I'll skip all of the other tools and resources that we offer, but if you are interested in learning more about that, feel free to reach out to me after the event or Arman. He'll be sharing his calendar link. So that's a super easy way to get in touch with us if you're interested in learning more. For today's event, it's presented by Hohmann and Barnard / Block-Lok. So Block-Lok is the Canadian brand of Hohmann and Barnard. So for any questions, you can head over to Hohmann and Barnard on Acelab. You can just use this little search bar at the top. Anytime you know exactly who you're looking for, you can type in the name of a manufacturer there. Head over to their page on Acelab, and then we've got this great contact button. You can just use that. That'll put you in touch directly with their team. So if you have any follow-up questions about today's webinar, about the products that we're going to be going over, you can feel free to use this contact button to get in touch. You can also explore more about the products from this page as well, save them to your projects. So it's a great resource to come to if you want to dig into this stuff more after today's webinar. All right. With that, I'm just going to give a few quick housekeeping items. So we did ask for AIA numbers upon registration. I'll also send over a form in case you forget if you included that or not, or if you want to request a certificate, you can fill that out on the form as well. And I'm going to go ahead and pass it over to my colleague Arman, who's going to give a quick little intro about Acelab, and then we'll go ahead and get started with the CEU portion of today's event.
Great. Thanks, Bo. And can you all see my screen?
Yep.
Great. Hi, everyone. I'm Arman. For those of you who are joining for the first time, I'm Acelab's Director of Architectural Partnerships. I work with architects on a regular basis and very personally to help them find the right products and make informed decisions for their projects on a day-to-day basis. I myself am a licensed architect here in New York and have worked on a range of projects with a lot of experience in multifamily residential, which I know a lot of the individuals that use Acelab work on very regularly. The program that I wanted to share with y'all today is our product concierge. It's a membership program that's completely free to anyone that uses Acelab, where we work with architects really directly by providing them on-demand material experts. A lot of architects that have been working with us have been asking for direct access to our experts in-house. And so over a year ago, we started this program and have upwards of 40 to 50 firms we work with regularly to provide them the expertise that they need. So the program encompasses a lot of different things. However, the main thing that architects really find value in is being able to ask material questions at any time in their design process, both about their project and also about their overall standards and library. So at any point in the process, you'll be able to access our material experts. I'll be your primary point of contact, and you can ask us anything about materials you're trying to spec or research on a day-to-day basis, ranging from things such as sealants and lacquer to like brick anchors like those that are produced by Block-Lok, and all the way into like exterior products, interior products. Any kinds of questions in your design process are available to you. What that really helps our architects do is make informed material decisions for their clients. Often it's hard to come to a client with the proper research, especially when you're working towards tight project milestones. And so what we're able to do is provide you with clear research and comparison reports between products that help you go back with informed selections. So one example of what this looks like often, in fact, just this past week, we got a question from an architect who was working on a multifamily project here in New York. and their client asked them about using EFIS. And so what we're able to provide in these scenarios is a degree of kind of backing to give the architect confidence that this is a product that's been used quite a bit. I think one of their main worries was water penetration in the cladding system. And so what we were able to show them was a manufacturer we work with regularly, Stocorp, who have fully vetted assemblies that use their own proprietary system as their weather resistance barrier, and then an entire system in front of it that allows water to pass through in the back. One of the best things about EFIS in this case was that they're able to produce incredibly beautiful facades as long as you're using them, above the first story. You can even replicate brick, almost to any exact color. And then more so, you have a full line of exterior insulation to improve the performance of your building. And so things like this are really helpful for architects that we work with, both younger staff at design firms and also, project architects, principals, and so forth, to help provide their staff with a lot of background knowledge for why they're making these selections. So to recap, you get a lot of information through this process. You effectively get a new team member as part of your project or your library. And you're able to make informed decisions. It saves you tons of time. We're able to do the research for you. You say your designer is almost like 10 hours a week per project. And the best part is that you'll start to enjoy working with materials again. So to get started, make sure to click the link that we'll drop in the chat. I know Bo just dropped a poll asking if you'd be interested in joining this program. It's completely free and no risk. So if you hit yes on that, I'll reach out to you and we can get a more informative sessions set up, and I can take you through the process as a whole. And then you'll get started with our concierge, which effectively gives you access to us anytime, but then you also set up 2 short 30-minute meetings a month. So it's almost just an hour of your time a month, and you get a lot of kind of value out of it. So that's my thing. Please reach out. The link's in the description. Respond to the poll, and I guess I'm really excited to hear about Block-Lok and some of the great products that they're working on there. Thanks.
Awesome. Thanks, Armand. Yep. Poll is still up for another moment, so feel free to respond over there. And without further ado, we can go ahead and get started with the CEU portion of today's event. So it's going to be presented by Mark Brusso from Block-Lok. Thank you so much, Mark, for joining. And we've also got Linda from the Hohmann and Barnard side listening in today. So she'll be available to help out with answering any questions. So just want to encourage folks, please submit questions to the Q&A box throughout today's webinar. We'll save some time to get to them at the end. And if we don't get to your question, we'll have a record of it if you submit it there. So looking forward to hearing everyone's questions and looking forward to hearing your presentation today, Mark.
Thank you, Bo. Thanks for the introduction. And thank you, attendees, for having me. I'm Mark Brusso from Block-Lok. I am their certified architectural representative in Canada. So I do a lot of in-person presentations in the Canadian region, and also have just gotten started with Acelab on this platform, which I very much enjoy. So a little bit about me. I'm a graduate from the University of Guelph in science, and I like to bring a lot of my scientific background from my post-secondary education into my role. I've also, in the early part of my career, spent some time working for a builder. So I do like combining the science and also experience on job sites into this role, specifically with building envelopes. So today we're going to do a general overview on water and what it does for the building envelope and construction best practices. Sorry, there was a little delay there. So just a brief overview of my presentation. This is a very generalized summary. We're going to look at how water is managed in the building, on the building envelope. I want to also identify some technical resources throughout my presentation that I think everybody should be aware of, whether you're an architect or a technical representative for a manufacturer or an engineer practicing in your respective discipline. There is a lot of resources in our day and age available at our fingertips right now that are really valuable. We're going to do a very specific review of the through-wall junction, which is a spot in the building envelope where a lot comes together in terms of water management. I am going to spend some time near the tail end of the presentation looking more about how water is an important component of construction materials and what how important it is to pay attention to manufacturer recommendations on mixing and using that. Going to spend a portion at the very end also looking at how water plays a role in cleaning insights and cleaning projects on their own. So I snuck this slide in here last minute, actually just before I hopped on the presentation, because we recently launched an initiative to start training some of our staff with very specifically with air barrier technical information. I thought it was really pertinent today because this statement is put out by the Air Barrier Association of America. I encourage you to look more into that resource as well and explore their website, because they have a lot of technical information on air barrier that's very relevant to all types of construction. But this really drew me in. One of the statements that we got quizzed on was it's very spelled out pretty specifically at the end of this document, and that the top reason for litigation in the building construction industry is moisture-related problems in buildings. So I thought it was quite relevant to put together a presentation speaking to that. What better way to start that out than looking at the rain cycle? I think some of you might recognize this from elementary school days, but thought it was also pertinent to show how in the building industry, we are all kind of caught in the middle of this cycle, how water goes from evaporation to condensation, then through the groundwater system and then back around again. And so in our roles, we're kind of left trying to figure out how we make this the most comfortable process possible. Back in the old days, way back when, the building science used to be a lot more simple. So these are stone huts in Croatia, and I actually stole this idea from John Straub, who starts his presentations out with stone construction like this. And it's quite humorous because he does explain how, you know, the roof, the walls, the doors, the windows, everything was rocks at one point in time. And these materials, although very basic and simple, I think we can all agree that they're not the most comfortable things to live in. I don't think this would quite cut it for comfortable living over the long term. So problem is when we introduce more complex structures and more control of the environment, we run this very ragged line of creating very comfortable environments and also creating environments which, if they're not managed correctly, can create issues with opportunity for water infiltration, mold, and other things. And there certainly are examples over time in history of where there have been consequences of building envelope being designed poorly and issues happening. And as I mentioned, water infiltration is one of those things. This story was in the news in April of this year, and this is a current situation in a condo building in Montreal where they had water infiltration, and 160 owners have had to been evacuated from this particular project due to water infiltration. So keeping this idea and keeping the building envelope at top of mind, I think, is extremely important. And I wanted to also share that I had mentioned earlier that I have some experience working for a builder at the early stages of my career. And one of the first projects that I started out of university was a high-rise project in Dundas, Ontario. And as we were starting out our introduction with Acelab, we mentioned the EFIS system as one of the a little in the introduction. This particular condo was an EFIS-clad system. We built this in 2005, and at the time, we had all of our engineers in place for Bulletin 19 reviews, architectural reviews, site superintendent in place. And so things were being done under the inspection of the condo corporation and the building department, all in line basically. And you know, fast forward another about 23 years later, I happened to be reading the paper, and there was a mention of a lawsuit that was involving this particular project. And I haven't been working for that builder for quite some time, but through reading through the newspapers, I found that what had happened was that the weep system, the weep holes in the EFIS system were left completely out. What ended up happening was water that was getting in behind the system over time had become trapped and led to a huge amount of corrosion requiring extensive repairs. And so that one little detail that was left out of this particular project resulted, excuse me, in the need for the EFA system to be completely replaced and reclad, and also some extreme corrosion results over the long term. So just to illustrate that, the functioning of a building envelope requires many components working in unison together, and even leaving out one small detail like a weep system can have humongous consequences. Excuse me. So building envelope, I always like to take a look at this slide and explain that it really is our first line of defense in Mother Nature. So it firstly sheds our water coming inbound. It's also our guardian for freeze-thaw cycles. Living up in Canada, I have climates very similar to the Northeast United States, and freeze-thaw is very much a reality this time of year, and it is responsible for a lot of damage on the building envelope. The other thing the building envelope does is it is a shell for other things such as airborne salts and coastal environments and driving rain. Very much a part of air leakage control, and it's also part of the insulation wrap of a building. Drainage is also a very critical component of the building envelope and something that is integrated into all of these things. And the reality is water is never absent from this part of the building. It's there and it's constantly moving in and out, whether it's the inside or the outside. So from the outside, we get rain and solar-driven vapor diffusion, capillary flow. And on the inside, we also have moisture coming in different types of things, such as from being inhabitants of the unit, we're dealing with moisture given off from showers, running water, cooking, and actually being ourselves and sweating and creating moisture on our own. So it's a continuous cycle of moisture going in and out of the building envelope. Generally speaking, in construction as a whole, if you were to think about what we do with water, the rule of thumb really is to get water back to its source as quickly as possible. And by that, I mean getting it to the ground so it becomes part of that rain cycle that I was talking about. So that means getting it off of our building materials into things like eaves troughs, on the sloped roof, down into the weeping tile and into the catch basins and through the drainage system. I think from observing this principle in any type of construction, anytime we see water sitting too long around a building, it ends up being a problem. And there's certainly evidence of this. And I like to call it what happens when water stays. And in masonry walls alone, when water stays and it stays wet and gets subject to things like freeze-thaw cycles and moisture, we get evidence of spalling and efflorescence drive. On the inside, when water stays present, we see mold and mildew issues and water damage. And then importantly, I like to look too at roof systems, specifically flat roofs, because positive drainage also is important on so-called flat roofs, because if water ponds and stays there, it has an opportunity to create an oxidative environment where the roof breaks down a lot quicker than, say, if we had a positive roof slope in that environment. So again, anytime water stays present on these building materials, it accelerates deterioration very quickly. One of the best and most high-performing building envelope assemblies that is very much at the forefront of our market today is the Rainscreen system. And it is a system that is excellent at shedding water. It's composed of four components that are going to be covered a little more in detail further in this presentation, but it is a system that's quite excellent at shedding water due to its design. And its construction, we're going to break it down in a few simple slides. It's worth to mention that masonry, even though we think of it as an old system, an old wall, something that's a little more traditional, it's actually considered the original Rainscreen system. In fact, that it is incorporating a drainage and a drying plane in its assembly. So masonry also qualifies as a rain screen system if we were to take a look at it and compare it to some of these modern rain screen assemblies we'll see a little further on here. And rain screen is also recommended in a lot of building science documents by some specialists that we're very fortunate to have in our industry, specifically up in Canada. We have a professor at the University of Toronto in our building science program, Professor Ted Kessick. He published a very interesting document in the 2000s, the early 2000s, in response to our glass condo crisis that we kind of have a bit of a unique condition up here. We had a boom of buildings that were constructed in the 2000s that were predominantly glass construction. And a lot of comfort and water infiltration issues arose from those. And Ted found it pertinent to write a document that addressed some of these issues. And he made some very, very great guidelines on optimizing multi-unit residential buildings for design. That's what the MERB stands for. In the bottom right corner there, rain screen was one of the recommendations for optimizing these designs and also for managing water infiltration and for overall comfort of the building. So one of the first components is rain screen's got a great outside skin that sheds water extremely well. And it certainly doesn't have to be something high tech, it can be something as simple as overlapping board. This diagram qualifies here as a rain screen outside envelope. Something could be a rough pine that is shiplapped can qualify as an outside rain screen, something that will shed water effectively. Rain screen is also well drained and ventilated, and that means air that may change in pressure from buildup of heat on one portion to the other will pressure equalize within the building envelope. So basically what that means is air is allowed to flow from one area to the next. If one part of the wall gets warm, that air will rise and naturally vent out of the top. So ventilation is part of the rain screen assembly. And with modern rain screen systems, we are seeing wide cavities and larger R values present in today's market. So on the left is an example of a rain screen in its initial stages with a rain screen clip system. And then on the right, showing some of the deeper cavity insulation layers that are recognized by some of these rain screen systems. It often also involves heavy-duty clip and rail systems, such as our HBRS rain screen clip and rail here, to accommodate an outside panel, which is your outside rain screen water shedding barrier system. Thermal shims and brakes are also something that can be incorporated into the bracket design, such as a Fabrica shim. And as I had mentioned earlier with the Air Barrier Association of America technical data, the high-performing air barrier is also a very important component of the rain screen system. So the air barrier is managing your air movement and controlling air leakage in and out of the building envelope. And another important thing to realize is although air barrier's primary function is to regulate air leakage, it also has a very important secondary function as a water resistive barrier. So that means that if water does get in behind the primary cladding, which is supposed to shed water, and it gets behind that, and there is a drainage occurring, that this barrier also is waterproof. So it's not allowing any water into the interior components. And high-performing air barriers can consist of things like STPE, silyl terminated polyether. So this is a hybrid fluid-applied air vapor barrier that functions much like a silicone and a polyurethane. So it's the best of both worlds. Silicone is also very commonly used. The differences I see in our markets in the US versus Canada is we do a lot of work up here in Canada with sheet applied systems, whereas the US markets are still working primarily with fluid applied systems. I'll argue I prefer fluid applied just in the ability to achieve continuous coatings and layers, and also a lot more productive in my opinion. This is one of my favorite materials personally. We have a multitude of options for designing rain screen. Wood qualifies as one. I personally like a lot of the European designs using wood. This is a Rhine zinc design. So Rhine zinc's a manufacturer, and their zinc panels are actually quite modern and interesting looking. So we have multitude of design options as well aesthetically with rain screen systems that are quite interesting. So I'm going to move over to the part of the presentation where I'd like to share with you some of the resources on the web, some of the institutions we have at our fingertips. And I like guiding some of the architects and designers in my region to these resources when I get questioned on details, because some of them are excellent at graphically illustrating some of the things related to best practices with rain screen and masonry. And one of my personal favorites is the International Masonry Institute. And this website is quite rich in its graphic ability to kind of portray good details that are so well illustrated. They really are well illustrated. And I had a firm of mine I had presented to in November in person for a lunch and learn that came to me with some questions and details for certain things around a through wall. And we had a discussion on best practices and things that we should look for in the through wall. When I introduced him to the IMI, he had not seen it before. I think he's a regular participant on there as well right now at this point. And I'm constantly going to the IMI myself to refer back to. So I'd like to, point the attendees today to this site. It actually has some very good details on rain screen, such as this terracotta assembly here, quite well illustrated, three-dimensional, shows all the key components, and basically everything is downloadable at your fingertips to take a look at. They do really good details as well with through wall and so forth, with the shelf angle, brick ledges, and the mortar retaining devices and everything behind that. So some examples here of something that gets beyond rain screen and into more traditional masonry assemblies. The other one I like referring to, and this one, the NCMA, the National Concrete Masonry Institute, they're very strong with their technical notes. So they're not quite as graphically robust as the IMI, but with their printed literature and their tech notes in written form, they have a very solid base of technical information at your fingertips, especially for masonry assemblies. They have a really good tech note on water repellents for concrete masonry walls I like to refer to when people have questions about that particular product and use in masonry systems. The other one I like too is the Brick Industry Association. So that website is gobrick.com. The BIA is very good with their tech notes. They read a lot like technical data sheets and their recommendations, but they're also really best practice focused and another great resource to make sure you have a look at and become aware of. Kind of going into the masonry cavity portion of rain screen systems, a little thing that I like to mention, because at Block-Lok and Hohmann Barnard, one of our core product components is masonry connectors and anchors for the veneer. I'd like to mention that in that cavity wall design, we need at least 1 inch of airspace to work. And that is actually something mandated under our standard up in Canada. Our standards in Canada and the US may very well amalgamate at some point, from what I've heard with our standards association. And the TMS standards in the US are very, very close to the Canadian standards. They're very, very close and very similar. So I think of design very, very similarly between our borders. And here's an illustration kind of what I'm talking about. When we look at details in this building assembly, the through wall and the water shedding layer of the masonry veneer, the adjustable portion of our ties and anchors lays in that very small space of 1 inch minimum. I understand in some of your respective territories, such as New York City, space is at a premium. So sometimes I will get inquiries of, air spaces of 3/4 inches or less because the tolerances are so tight. But the reality is under the constraints of design, we really do need at least an inch for things to work. So that is something I just wanted to mention. So this is another slide from the IMI, again, to kind of illustrate how important it is to detail for water management in the building envelope. Because when we have things coming together, and by that I mean corners, window details, the through wall, and flashing, there are many, many different ways and angles for things to allow water in if not detailed correctly and with good water management practices. This is another really great slide showing some of the best things to incorporate into sills and areas where water penetration typically is an issue, at windows, at through walls, wherever there's a change in plane or a seal detail needs to be located. These IMI documents are exceptional at showing some really good things to do and consider in terms of managing water with your detailing. Another important aspect of managing water and moisture in the building envelope is that under the standards, and by that I mean the TMS and the Canadian standards, is that corrosion resistance is mandated for our connectors. And what that means is that these connectors, A, have to be either hot dip galvanized or B, stainless steel. And that's simply for the fact that the building envelope, that first plane of water shedding, is subject to moisture at any time. So that brick veneer can get wet. It could stay dry for a very long period of time, but because it does see moisture vapor drive in and out, it is subject to corrosion. And connectors, ties, anchors that have been compromised. There is evidence such as this corroded brick tie on the left, and then its rust imprint on the far right. It does cause a compromise in that tie strength over a period of time. So corrosion equals wall failures. This is actually a quick little video from Montreal of a collapse of brick, just missing a car on the street, no volume, because that would probably have been really loud. And then a couple hours later, another 2 stories comes down. The first collapse missed the car. The second, luckily, nobody was there, but I'm not 100% sure why that collapsed, but it could be that ties were left out altogether, or it could have been that the ties have corroded. But my point is that we need ties and connectors in the envelope to hold things up. So moisture may have its way at some point, and it seems to more often than not. I did want to bring up this point because this question comes up. There are certain building conditions where stainless steel is required over galvanized when we're talking about these things like connectors and anchors. And this would correlate with the TMS standard as well in the US, but this applies specifically to our Canadian standards here. And I call it the high building condition. And this is when exterior masonry is more than 13 meters above grade. And we have a climate condition that is reflected by a driving rain index. And what that is the mean annual rainfall multiplied by the mean annual wind speed, and you arrive at a number. And if that number is greater than 2.75 and we have a high building masonry condition, i.e. 13 meters above local grade, we're mandated to use stainless anchors in the masonry veneer. And the other thing too is if we're within 1 kilometer of a coast, we're also mandated to use stainless. So there are places where we have to use the more expensive option, stainless steel, in the building envelope. So we kind of looked a lot about how water does things that are damaging to the building at this point. But now I wanted to point out that water isn't always the most evil thing out there, and that if you look at it, we really do need it for a lot of these materials to come together and make buildings as well. So we're going to shift into the mixes now. So mortars and grouts. One thing I like to keep in mind, whether it's doing a home renovation and putting in a new fireplace or installing a TV or mixing mortar for something like a type N, is it is always a lot of effort to read manuals and follow manufacturer's instructions, but the truth is that it's probably the smartest thing that anybody can do at any point in time. So the closer you can follow the technical documents, the higher the chance is that you're going to have a favorable outcome if you follow the literature. And there's also an expression that says that which is measured is improved. And nothing could be more true than measuring water. So my example is a data sheet from a manufacturer, and they're very explicit in their mixing instructions of water content for mixing mortars and type N grouts and so forth. And it's actually really important because that water to cement ratio, so the amount of water that is mixed into your dry mix, is really going to be a critical component to how your mix turns out when it goes through the curing steps. So everything is actually optimized when you are following the correct procedures and recommendations to achieve those optimal ratios. So if you measure things, you're going to have better results over the long term. And just make sure this doesn't play with volume because it can be a little loud. So mortar is really important in the plastic state when it is wet, because when it is mixed correctly and with the right amount of water, it's very workable by the bricklayer. And by that, I mean they can lay brick productively. And so the mortar inherently has this characteristic to it that it stands on its own and it doesn't fall out, and it is able to almost behave in a way that allows these guys to move quickly. So it's not just falling off the mortar board and like a pile of sand being washed by the beach, but it has some fatness and body to it. There's a video of the bricklayer competition that we have up in Ontario. And this is actually the national competition is at the World Concrete this year. We're involved with Spec Mix as a sponsor. So these guys try to lay as many bricks as they can in an hour, and they win big prizes for it. But my point is that water is really important for workability in the plastic state of mortar and grout. Now, in the hardened state, things like compressive strength, durability, and water shedding ability come into play. And so with these water to cement ratios being optimized, we get the compressive strengths that are mandated by the standard being achieved. And we have the best water shedding ability also recognized. So those two states of mortar existing together are very, very important. And following those water to cement ratios will bring out that outcome to the best of its ability. The second thing, the last second subject on mortar and grout is grout. Now, grouting is a really critical component of block walls and in structural applications. There's one thing I can say about grout. It's also all about water. Now, grout requires a lot of water to get it to flow. And so that's another thing that I like to say is we want to follow the manufacturer data. So always start by mixing a grout following the water content recommendations to get those water to cement ratios optimized, because everything falls into place. Again, we will realize good compressive strengths and as well good consolidation. And then the other thing is to, when I say it's all about the flow, that means we get that grout into all those voids that it's meant to go into. Following back into the building envelope, the through wall, this is the spot in the building envelope where moisture management is critical. This is where everything really comes together through support, drainage, ventilation. We have a lot of details in here, and I'm going to cover just some of the basics of that. So it's where the water really comes out if it does happen to get back there. Ideally, we don't see anything get back at the back behind the brick veneer because, you know, the brick's doing its job in the first place and shedding water as it should. But there are some things we like to incorporate into that through wall to make sure that those details will optimize drainage and so forth. So it's no secret that the through wall can be built incorrectly and it can incur moisture and damage and breakdown over time. So this is a restoration project I was involved with, and this is an example of a shelf angle that has corroded over a period of time. What happens is when the shelf angle corrodes, steel will basically expand as the steel begins to separate and these layers form, almost kind of like how water expands when it turns to ice. Rust will expand and do what is called rust jacking and force brick off of the shelf angle and try and project it off of that shelf angle. So this shelf angle, as you can see here, there's been some demolition done to expose what's been happening, but you can see there's very little opportunity for water to leave on this detail. In fact, if you look close enough, you can actually see a bead of caulking continuous along that through wall area where that lip of that shelf angle is. So it's completely blocking water from getting out there. Another example of the same thing happening, but with a little better detail of that behind the brick, there is absolutely no space whatsoever for water to drain out. The mortar has completely plugged that through wall area. We're going to show what we can do to improve that issue where water plugs the back of that. So if you ever look at a brick wall being built or a restoration project, take a look, and you were to take a look and see this wall, would you answer the question with a yes, that do you have enough cavity here? Do you have enough space for anything to happen, for water to flow or for any ventilation to occur? And you can see this, in this particular case, absolutely not. There is no space there at all. Maybe a 1/4 inch, certainly not enough to allow anything to come out or to drain correctly. So always be asking the question, do we have enough cavity space here for things to work and to drain properly? When we're talking about replacing shelf angles, just a little sidebar here, we have an opportunity to improve thermal performance by offsetting the shelf angle from the outside, from the wall, and improving thermal performance. So this is an example of our TBS system, which is very different from the traditional shelf angle where it is directly mounted to an embedded system. These are offset from the building support structure and allow insulation to pass behind the shelf angle. And also they reduce the amount of contact to the wall behind it by using inserts and small contact points of metal to metal so that the thermal transfer is reduced. It's also common to see this achieved with the fast bracket method. So another opportunity to improve continuity and thermal performance for the through wall area. So on that subject of that through wall continuity, you had seen previously that detail or that photo where the mortar was completely plugging that air cavity space. And a mortar retention device is very important incorporating into that airspace to prevent that. And what it essentially does is this creates a break in the plane of of those mortar droppings that inherently are going to fall behind the brick. It's very much almost impossible to completely stop any droppings from going behind the wall when you think of the way brick is laid. And in order to prevent that from building up, introducing this dovetail design of the mortar trap keeps an open drainage plane in place to manage those droppings in the backup. Now, I thought this was kind of a neat slide, but it could be exaggerated a little bit because weep vents or weep cells, they're also mandated under our standards. And I was mentioning my project I was involved with in terms of the EFIS fail that happened, and it was a different type of weep system altogether, but the common thread here with weep systems is that it allows moisture to drain at some point in a critical junction. And we're allowed to even leave a space in the bottom of the through wall for a weep to be present. But I did stumble across this interesting slide with the mouse. And then I look at my own house, which has no cells, or it is a completely open space between the brick. And I'm like, I don't know if a mouse is going to be able to fit in there. That looks pretty darn tight. So this picture, I have a feeling, has been managed a little bit, but it does make me think maybe weeps with that are actually a solid material like our cell vent or some of the stainless weeps, maybe they are a good idea to keep those critters out. But the main point to gather here is that they're required by the standards. Through-wall is also an area where we want to see high-performing through-wall flashing systems to manage the moisture. And really what that is doing there, this is managing any incoming moisture here from getting into the back of that, behind that flashing system, and that gap or that any area where that block is meeting the slab. And it is also incorporated into your air vapor barrier system above and a drip edge below. I do like to mention end dams for detailing at through walls because they're not always used because they're an additional product. They may be viewed as an extra, something as another accessory to worry about. However, these prefabricated end dams, they really do clean up these details in the corners quite well. They manage that finicky area where we have to bring the fabric areas together, and they're a great accessory to really clean up the detailing in these areas, and they do a great job in doing so. So there are consequences to bad through wall, and they can be seen when we open up through walls that have been showing signs of deterioration. So it happens. Drip edges, they're kind of the last component of this through wall junction that I think are worth mentioning. And really, what are they for? And I brought in a couple of extra slides to kind of illustrate what they do. And they don't just bring water out from that through wall, but really that drip edge, that ends up doing is breaking the surface tension on water, and kind of, it's almost like a kickoff from preventing that water droplet or that water that does eventually run down a building, whether it's from rain on the outside or from anything coming on the inside. It breaks that inherent ability of water to kind of hug and curve around and try and soak the brick below it. It breaks that surface tension and makes it drip off the building envelope. So it's, again, getting that water away as quickly as possible from soaking anything below it. So it's a really, really important component of that through wall detail is the drip edge. It breaks the surface tension, the water kicks off, it does not soak the building envelope. So we are getting near the end here. We're going to talk a bit about cleaning. So cleaning happens as its own portion of a project. Sometimes it can be a job all on its own. It may not be needed to be done at the end of a construction project. It may be a restoration project, but it is something that gets done on a regular basis because over time, things may build up, such as atmospheric pollutants. We may see hasty workmanship or a brick that is installed very quickly with a lot of workmanship contamination. And so the real thing to take home with cleaning is it does require a lot of water. And the thing with water, its function in the cleaning realm is that water is the universal solvent. So it is what carries all of these ingredients that are active in creating a lifting effect of the offending contaminants. It's important in pre-wetting a lot of these materials to be suitable to apply the cleaner ahead of time. And then water also is the key component to the rinse phase. So pre-wetting, applying the cleaner, and it's actually the main body of a lot of the cleaners. And then the rinse portion. So water is a really important component of cleaning. And we do work a lot with cleaners in our Diedrich arm of our department here. So make sure I get ahead of the volume on this. And it thankfully didn't play the volume. But just a little video here to illustrate, cleaning is basically chemistry that amplifies production. We could try to clean these structures physically with no cleaners and detergents, but we'd probably spend a heck of a lot of time trying to achieve that result without chemistry to amplify production. I kind of look at it as trying to clean your dishes without detergent soap. It's sort of the same thing. You're going to get the best result with some sort of chemistry. That's what we're trying to achieve here. Now, efflorescence, it's a common headache in the masonry world. I'm sure many of you have had projects where this comes up, and the question is, oh my gosh, what do we do? It's white, it looks horrible. And that's right, it really does not look great. Anytime you have staining, we can all agree it is definitely not a favorable thing to see. And it's really the building kind of saying to you, water is trying to get out somewhere. And the reality is it's also bringing a lot of salts with it. So all of the materials we use in masonry construction, by nature, they contain a lot of salts. And that's really, at the end of the day, what efflorescence is it's a reflection of that water drive from the inside outward, saying, water's trying to get out by quite a bit. And it shows up in the form of these salts. It's pretty rare to see white staining from any other kind of source, but it can happen. There are lime stains. There are other areas where, white films can be present, but a lot of time when we're talking about masonry, we're seeing white staining like this, and it's been, present for a period of time and it reappears. It's telling you that water and vapor drive is very much a reality here, and it's a reflection of that, because the salts are dissolved in the water coming out of the building envelope. This is really just a rotten, awful picture of everything going wrong. I call it the poor wall, but yeah, efflorescence, it's also kind of showing you other big issues. There's more going on here on this picture than just efflorescence. There's just all kinds of water and dripping and freeze thaw happening. And I'm surprised that brick looks as solid as it does, but this is a very extreme case of a very, very tormented wall subject to efflorescence. So before we conclude today, to kind of wrap up, our discussion on water and sort of sticking with the theme of cleaning, I wanted to, explain kind of that concept of using water on a cleaning project that came into my lab recently. And this was with a colleague that I work with. And this was on a cast stone wall. So I thought we'd take a look at this as a last project to kind of see what we can come up with. But again, the theme here is always following the manufacturer data as closely as we can. I know we're all busy, but I always say the best results can be if you follow the instructions of everything you can, and we'll always get the best results. So cast stone, I had to kind of reacquaint myself with this product, and that it is in fact a manufactured product. It's not natural as you would think, that stone and you would lend you to believe, but it's a manufactured product. So it's made in the plant. It is a cementitious product, and it is something that we will lay up much like a brick unit. And so this project came into our inbox, and there was some cleaning that was done on this particular cast stone wall with some of our Diedrich product. And there were some unfavorable results. So one of them was inherently a run on below the weep line there. You can see some of the staining. And then on the right, a lot of staining also around the mortar joints, and then also under that tarp, a lot of film. And anytime you see white and film and any staining on something like this, it's an unfavorable effect. And so, we're just doing some preliminary investigation on this particular cast stone. What I found is that, I took a look at that manufacturer's literature, because I didn't know really anything about this project until we started diving a little bit deeper into it. So we asked some questions on what was used to clean. And so we found out pressure washing was used. And I went to the manufacturer's website and found, okay, firstly, high pressure hoses not to be used for cast stone. So it can result in damage to the fine surface. That's a possibility that we get an unfavorable effect. The other thing we asked was what was the dilution for the cleaner used? We weren't 100% sure on that. That question wasn't really 100% clear. But again, the dilution rate also very clear on that stone manufacturer's website, and that it has to be a relatively weak mix, no more than 10% acid in the volume. So we're talking a very highly diluted solution. So point is take quite a bit of care. Take care using chemical cleaners, and also don't aim the pressure washer at the weep joints. And going back to the slide here, it was clear that a lot of the water was getting directed into these weeping areas, just simply by the fact that it's coming out from the very top down. So point is that a lot of times is that the unit manufacturers, in conjunction with the cleaners, both together are going to have their own detailed cleaning requirements. So if you do get the things coming up that aren't aligning when you're talking a cleaning project or a cleaning job, most of the time the manufacturer's literature is going to point you in the right direction to get favorable results. So point is, again, when it comes to mixing and waters, the best rule of thumb is follow those manufactured details and data sheets as closely as you can, and you're going to find that you're going to get a lot better results most of the time. So we're here at the end. See, we've got some chat, red lights. So
All right.
this is the fun part of the presentation. I always like answering the questions.
Yeah, we've got a few minutes left, so feel free to send some more questions in the chat if you have them. If we don't have time to get to them, we'll have a record of that as well. I'll start off with just reading out our first question here. What is your best strategy for bridging the architectural detailing to proper execution on the job site? There's an obvious divide between architects and contractors that has been created over recent decades, and I do think we are seeing a better relationship between the two with design-build contracts, but sometimes builders still want to take shortcuts and or do it the way they've always done it. How do you bridge this gap?
First of all, I honestly love that question because that's near and dear to my heart every single day. And it's on, I think it's the biggest struggle we have in the architectural and design community. How do we do that? I can answer that how I do it. When I'm talking to people like yourself with regards to design and things like best practices, I think, first of all, we keep in mind our codes are there to make sure we stay compliant to the laws, but we also have to remind ourselves that they're kind of the bare minimum that we have to do to actually be not breaking the law, and we can be better than the codes. So I always like to say we can try to strive for best practices and the best materials we can, and detail as close as we can to 100%, which is unrealistic. But if we try to do our job as close to 100% as possible, because we know it's going to get knocked down on the real job site, then we're going to have a greater chance of having a better outcome. So that is a struggle that's hard, because I know everybody on this call understands that, because it becomes this, the fine line between cost and the best materials and the best contractors and the best outcomes. So it's a ragged edge we run every day. Mm-hmm. So the way they have always done, exactly. How I was kind of illustrating the difference between galvanized and stainless ties and how you have to use them in certain conditions. I've run into projects where stainless ties should absolutely have been used on a high rise, and it was galvanized ties that got installed. Is that building going to incur a collapse in 10, 20, 30 years because they chose galvanized? We don't know, because it all depends on how well that brick veneer manages that moisture over the long term. But to answer your question, I think the answer is we try and do the best we can in the design phase, do the best we have under our control, because there's some stuff we can't control. So hopefully that answers that question. I know that was kind of long and rambly, but yeah, shoot high and try and recommend the best you can when bridging that gap, because cost and the spending aspect tends to drive the quality down inevitably. So the more you ask for and the more quality you ask for, the higher a chance you may achieve that. Efflorescence eventually stop if it is cleaned off, or will it always persist? It will always persist if the condition of the vapor drive or water trying to get out exists. So I will answer that question to, people asking that, when it gets cleaned, is that going to solve the problem? Not always, because if the water issue remains and there's active water coming in from above, or if there's a high level of exposure, it could also be a very poor building envelope, like a very poor air vapor barrier as well. So high levels of vapor drive from the inside going out can also express efflorescence. So sometimes efflorescence cleaning is just very much an aesthetic option that buys you some time. So as long as the water issue is there, the cleaning requirement can exist. So it's kind of what you resist persists, basically. So yes, it can persist if the water management issue is not dealt with.
Mhm.
Okay.
All right, and with that, it looks like we are at time. So if anyone has questions after today's webinar, feel free to head over to Acelab. You can get in touch with Hohmann and Barnard and Block-Lok directly over there. And yeah, just wanted to thank everyone in the audience today for coming out today and for participating in today's webinar. And thank you so much, Mark, for the wonderful presentation. And thanks, Linda, for joining today as well. All right, cool. Thanks, everyone.